You hear the word evolution, and a few things probably pop into your head, right? Well, what if I told you that some of the most common ideas about it are just plain wrong? Yeah. In this explainer, we're going to dig into the biggest myths about how life changes, and we'll start with probably the most famous phrase in all of biology. Survival of the fittest. I mean, it sounds so simple, right? The strongest, the fastest, the toughest, those are the ones that make it. And hey, even Charles Darwin himself ended up using the phrase in a later version of On the Origin of Species. But the way we use it in pop culture today, oh man, it's created one of the biggest misunderstandings in all of science.
And that right there, that's the core of the problem. What does fittest really mean in a biological sense? Because I'm telling you, it's almost definitely not what you think. Let's break it down. All right, so first things first, we've got to totally separate the idea of fittest from our modern idea of just, physical strength. In the great game of evolution, being the biggest or the strongest doesn't mean you automatically win, not even close. See, for Darwin, fittest just meant the best fit for a particular immediate environment. A great way to think about it is like a key fitting into a lock. During a huge famine, a tiny little mouse that barely needs any food might actually be a much better fit for survival than a giant rhino that needs a ton of food. See what I mean? It's all about context.
Okay, so if it's not just about being the strongest, then what actually drives evolutionary change? What are the real engines behind it all? Well, it turns out there are a few key forces working together here. Everything, and I mean everything, starts with mutation. These are just random changes in an organism's DNA. And the key word here, you got to remember this, is random. A mutation doesn't show up because an animal needs to grow wings or something. Nope, it's pure random chance. This just creates the raw material, the stuff that evolution can then work with.
So if mutation is the random idea generator, just throwing stuff out there, you can think of natural selection as the editor, and it's a very strict, non-random editor. It's really just a filtering process. Traits that just so happen to be a good fit for the environment, they make an organism more likely to survive and have kids, and those are the traits that get passed on. It's not some active force choosing things, it's more like a passive sieve filtering out what doesn't work.
And this chart here makes it super clear. Natural selection is non-random, it's driven by the environment, and it leads to adaptation. But there's this other force in the mix called genetic drift, and it's completely random. So picture this. You've got a bunch of beetles. Some are brown, some are green. Then, oops, someone accidentally steps on most of the green ones. Well, now the brown trait is going to become way more common, right? Not because it was better, but just because of pure chance. That's evolution by dumb luck.
And all of this leads us to another massive misconception. This idea that evolution is like climbing a ladder, always progressing, heading towards some perfect final form. It's just not. The biologist Francois Jacob absolutely nailed it back in 1977 when he said natural selection is a tinkerer, not an engineer. Think about it. An engineer starts with a blueprint, right? They have a final goal in mind. But a tinkerer, they just mess around with whatever parts they have lying around, making little fixes and adjustments as they go. Natural selection is a tinkerer. It has no foresight, no grand plan. It can only work with whatever genetic variations happen to be there at the time.
And this whole no-goal thing also means there's no single winning strategy. You might think, well, being average is probably the safest bet for survival. But that's not always true at all. Depending on what the environment is throwing at a species, natural selection can actually favor the extremes.
All right, so sometimes being average is the best way to go. This is what we call stabilizing selection. A classic example is human birth weight. Babies that are too small or too large historically have had lower survival rates, so selection tends to favor babies right in that sweet spot in the average range. This basically keeps the population pretty uniform.
But what happens if the environment changes? Well, then you might get something called directional selection. This is where one of the extreme traits suddenly becomes the big winner, the most advantageous one. And this pushes the entire population's average in that direction. Think about giraffes evolving longer and longer necks over time to reach higher leaves. That's directional selection in action. And then there's the most dramatic one of all, disruptive selection. This is wild. It's when the environment actually favors both extremes, and the average individuals are the ones who lose out. So for example, say there are only really hard seeds and really soft seeds for birds to eat. Well, finches with either huge, strong beaks for cracking the hard ones or tiny, delicate beaks for the soft ones will do great. But the birds with medium-sized beaks, they can't handle either type very well, so they struggle.
This can actually split a population right down the middle, and it might even be the start of two brand new species.
So, if evolution isn't some steady climb towards perfection, then what is it? A more modern way of looking at it suggests it's less of a climb and more of a race with no finish line. And this is the central idea of a theory called adaptive tracking. It basically says that because our environments are always changing, populations are constantly trying to adapt to a target that's always on the move. And the big takeaway here? A species is almost never perfectly adapted, because that finish line just keeps getting pushed further away.
So here's how it plays out. Step 1. A new, beneficial mutation pops up, and it's great for the current environment. But by the time that helpful trait starts spreading through the population, whoops, the environment has already changed. Suddenly, that amazing trait might be totally useless, or maybe even harmful. The species is always playing catch-up, always just one step behind.
Okay, so all of this brings us to the big one, the question everyone asks. What about us? What about humans? With all our technology, our medicine, our cities, have we somehow just stopped evolving? Have we hit the brakes on the whole process?
Let's do a quick lightning round and bust a few final myths about our own species. Myth number 1. Evolution means everything is determined by your genes. Nope. Reality, the environment is absolutely crucial at every single stage. Myth number 2. Adaptations have to be there at birth. Wrong again. Think about it. Your teeth, your facial hair, they show up when they're needed. Myth number 3. Evolved traits are permanent and unchangeable. Not true. If you change the input, you can change the output. You know, wear gloves your whole life, you won't get calluses. And finally, the biggest myth of all, humans have stopped evolving. Absolutely not. As long as some people have more kids than others for reasons linked to their genes, selection is happening. Period.
So, what's the big takeaway from all this? Evolution isn't some neat and tidy ladder to perfection. No, it's a messy, goalless, never-ending chase after a target that's constantly moving. And when you think about us, humans, our environment, everything from our climate to our culture is changing faster than it ever has before. So the real question isn't if we're still evolving. We are. The real question is, where is this frantic race taking us next?